Okie doke, ladies and gentlemen. This is my time and Spark and yours. So I encourage you to ask as many questions as you can. We've got 1 hour. The weather is good. It's so good that I apologize keeping you here. Yesterday I went to the beach and I saw all these, people who are having fun. I hope you will have as much fun as they did yesterday or they will have today. So this is about internals. So again, I encourage you to ask very deep, in-depth questions about how Spark works. So thanks, Akmal, for your introductory talk about Ignite and Spark. So you pretty much know what Spark is or what can Spark do for you. If not, ask questions. So this is about structured query because as Akmal said, I'm gonna refer to some words of Akmal because he did a great intro to Spark. He made some statements I could not agree with, but it's not the point. The point is that he said, and I did agree with him, that structured query and data frames are the bread and butter of Spark these days. So as of Spark 2.x, you should be using data frames or data sets. Now the question comes, what's the difference between data sets and data frames? And the answer is very simple. For Python developers, there are no differences. For Scala developers, there is a huge difference, and that's the reason why we use Scala in the first place, type safety. Data frame is just data set of rows, while data set is just data abstraction over any data you can think of, okay? It can be structured as a row, but it can be structured as a row-like data structure, let's say case class X, okay? So that's a just type-related difference. No difference at the very low level, okay? So Spark doesn't care whether you care about data frames or data sets, okay? To some extent. So we are talking about Apache Spark 2.3.1. This is the latest and greatest. So I love working with the latest and greatest because this is what can challenge my thoughts, my beliefs, my understanding of how things works these days. So we are dealing with 2.3.1 and specifically about Spark SQL. And all Spark SQL became de facto the data or the module of the other modules available in Apache Spark. So if you heard about Spark streaming, and you did during the last talk, well, Spark streaming is dead. You should not be using it, okay? You should be using Spark structured streaming because the difference is that Spark streaming uses RDDs, while Spark structured streaming uses Spark SQL. Okay. And Spark MLlib, there are 2 packages. One is based on RDDs, while the other is based on Spark SQL, and you know the difference. So I'm Jacek Laskowski, so welcome all to my talk about Spark SQL, internals of Spark SQL, and how things work under the covers. I'm focusing exclusively on Spark with some because, time is not a stretchable thing. So I'm focusing exclusively on Spark and takes a lot of time. But if I find some time, I'm also looking at Kafka and Kafka streams, especially Kafka streams recently, just to compare what it adds beyond what Spark could do for you out of the box. I assume you are using Spark already. I'm doing development, consulting, training, blah, blah, blah. Reach out to me using Jacek, Yapila.pl. That's my company, Yapila.pl. And I'm independent consultant, so have your time and give me your time so I can respond. But you can also follow me on Twitter, Jacek Laskowski, or just for more information about Spark-related stuff. I'm best known by my ebooks about things I love working with, and my customers pay me for. So, mastering Apache Spark. Everything I'm gonna say today is already available. So, if you don't like my way of sharing what I've already described, you can just leave right now. Or you can stay and hear my take on the content you can read. So, rather than reading, you can hear what I've got to share. Mastering Spark SQL, that's the content we are going to cover today. Then there is another book about Spark structured streaming, about Kafka streams, and the last but not least, Apache Kafka. So these are my 5 books I'm updating fairly regularly, and because, you know, things change. And this is where you can find me too, Stack Overflow. So things Spark related are my things. I'm gonna see things how you see in production, so that's why I'm using Stack Overflow. That's all about me. Now time to talk about Spark. So Spark SQL. Spark SQL is all about structured queries. And the point behind, or the beauty of structured queries is that they can get optimized better than you could even imagine is possible. Why? Because Spark structured streaming, because structured queries know the data that it's gonna work with. It can apply optimizations you don't have time understand or apply because it can be done automatically. Then we go through different query languages. There are 3 query languages supported by Spark SQL. Project Catalyst, you may have heard of, QueryExecution, and other things. Okay, so structured queries. Structured query is just a query over data with known schema, with known shape. So your data has a structure. That's important to know, to remember. Whenever you want to apply Spark SQL, think about your data having some structure. So, is a picture structured data? Not so much. It's just a bunch of bytes with some structure, but this is not the structure I'm talking about. I'm talking about strings or types I can apply to your data. Strings, bytes, binary, well, they are not very good to store, but longs, integers, big integers, other big numbers, okay? So if you can say something about your data, that's probably use case for Spark SQL. So schema is just a tuple of 3 elements, okay? You need to know the name of your field or column, whatever you call it. This field or column has type. Type because Spark needs to know how much space to reserve for your data, okay? Remember, we are talking about big data, huge amount of data. And I am not specifically describing what big data is because I leave it to your understanding. So if you can think about data that can fit into your one laptop, fine, call it big data. But the beauty of Spark is when your data cannot be processed by 1 or 10 machines. You need thousands of machines. In other words, think about Spark as a coordinator of processing across machines. That's why it's called clustering compute platform. Okay? So if you need to schedule or trigger a job or processing across different machines in different regions, in different locations, that's Spark. But this is very low level. Very low level of Spark. But hey, you are not dealing with problems like how to distribute your computation computations because you know that you can use Spark SQL. The beauty of Spark in general, the beauty of Spark comes where you need something like higher level like Java, programming languages like Java, Scala, or even SQL. So Akmal mentioned SQL in his presentation, and he did this point about saying that SQL is a very fine language to query, to do some processing. And you know what? I'm over 40 now, And back then, when I was 20 something, I thought that SQL is for very old people, me, so might be that I grew up, and it's a dead technology. Okay, it's a dead language. I was into Java, Java EE, all this stuff. Then I switched to Scala, you know, all modern languages. It's only now when I understood the beauty of SQL. It's a very concise and simple language to do not so simple processing. And with Spark, you can do this processing over distributed clusters. Okay? Think of it. It's a fairly complicated topic or topics to talk about distributed computations, large data sets, and SQL. And now, with this, you can think of Spark that does this for you. So you don't have to worry about it. Okay? So we've got this SQL, and why is structure important? Because we are talking about big data. We are talking about data that has to have a storage, or the data has to be stored somewhere. Good? So if we think about even caching solutions, what was the name? Ignite, exactly. Spark, Ignite. So Ignite, you need to think about storage. So what's the storage for Ignite? RAM. So memory, correct? It's a memory. Can you think of memory as a storage? Oh yeah, with Ignite, that's pretty much simple. Okay, there are other solutions to make your RAM disk aware or disk looking. Okay, so we need storage, and storage is also disk, but disk is slow. So we are thinking about memory. So the more you can put into memory, the better for any computations. Now we are talking about Spark SQL, and Spark SQL can leverage the information about your data. So the less storage needed, the better. Okay, so query languages in Spark SQL, there are 3. Well, there are more than 3, but if you look at programming languages supported. So we've got good old SQL, okay? This is fairly nice programming language. Well, semi-programming language. This is definitely query language. Then you've got untyped row-based data frames. Untyped meaning that Scala developers don't really like simplicity of data frames because it hides the type behind this row data abstraction. So Scala developers, type-safe developers, prefer data sets. But don't use data sets in your applications. Why? Because once you start thinking like a Scala developer, you will take information, important information from Spark, so Spark can optimize your queries. Why? Because when you start typing your code, Spark cannot analyze what you typed. It's already compiled. And even though there are decompilers, we need humans to understand, or AI, to understand what this code does, correct? So it's kind of like heavy analysis of what you may have written using this API, which means you are losing some optimizations that can be easily leveraged in this row-based data frame. In other words, use both to make your code more beautiful for Scala type-aware developers, type-savvy developers, as well as data frame for faster processing. It's a trade-off. Okay. And we've got this other axis like Scala, Java, Python, and R. And let me ask you this question. Why is it important that Spark supports 4 languages? It's a nightmare to maintain, correct? So why is it important to have all these 4 languages, especially Python and R? Sorry? You are thinking too much about technologies. But behind technologies, technologies are for who? Not for me. For you, for you, for you. For humans. for people who are out there laying on the beach or beaches, you know, having fun. But now, come on guys, we need to combine all these great minds and come up with something brighter or crazier, okay? So these people are data scientists mostly, or data engineers. These are heavy coders who doesn't understand the beauty of lying on the beach and being in Odessa and seeing sun. The only sun we can see is the old Sun Solaris operating system, remember these days? So this is the only sun we can accept. Our bodies, our IT bodies can accept. Yeah, oh yes, yeah. I can see by the color of your skin. Okay, so structured query language. So Spark supports SQL, and you know it already, okay? Just let's move on faster a little bit. And by the way, do you have any questions? Yes.
What about Scala developers? What can you say about them?
Oh, they are very crazy, nice guys. And they are very friendly. They share their knowledge all the time. So, well, what can I say more about, you know, Scala developers? And by the way, since we mentioned two languages, Java and Scala, I'm a Java champion. So just before I switched to Scala, I was appointed to, nominated to this, you know, exclusive group of Java developers, Java champions. So together with other Java champions, I should be promoting Java. And I do promote Java by JVM, Java Virtual Machine. Java Virtual Machine is a very nice piece of software, so I'm not going to leave JVM, but I definitely am going to use the best tools available on JVM, which among them is Scala. So Scala is a very beautiful language, and that's the reason why Spark uses it. So data frames, data sets, you know it already. It's a boring stuff, okay? So Project Catalyst, that's something I'm not sure you've heard much about. So Catalyst and Tungsten are the new names tied to this Spark 2.x release or releases. Catalyst is about making your world your another matrix. Okay? In a sense that you see flying numbers and you can see people walking on the streets. No, I'm kidding. So, Catalyst is a way to represent anything in a tree-like way. So, Catalyst created a data structure, or offers a data structure called tree node. And as you know, tree can have 0 nodes. It's an empty set. It can have one node itself, but it can build out of this to create tree. Okay? Anything, most things in Spark SQL are trees. Okay? So when you understand this little piece, that everything in Spark SQL is about processing trees, you understand pretty much how Spark SQL works under the covers. If you think about rules processing queries, queries are trees. So this rule to optimize your query is a rule processing a tree of operators, logical or physical operators. Having said that, you can think about your rule processing this recursive data structure going down or up the tree. Okay? And if I say that you can build trees of trees, multi-trees, because your expressions in select statements are also trees, things get nicer. A little bit. So Spark does this tree processing with rules. And the rules do nothing but manipulate tree nodes. That's it. And that's still about Spark. Good old Spark. Okay, so we've got tree node. Oh, I apologize for this. So if you look at these slides, you know, they are already published on my GitHub. So when you look at this slide, you see the code of tree node. And tree node is an abstract class to represent something generic. It's for Java developers, since there was a question about Java, it's a generic class. Okay? For Scala developers, we call them higher typed types or higher kinded types. It's just a generic type, another name. So tree node accept another type. It contains. It's a container. Okay? And the point is that it's a recursive data structure. Okay, and tree nodes, the one and only nodes available in Spark SQL are query plan, which is the base for any queries you can create in Spark. The very first query you create, after you hit enter, it's gonna be logical plan. And there are 3 logical plans. And 3 different logical plans, but they are described by the same data structure. And then there is this physical plan called Spark plan. And the last but not least, expressions. Expressions like x equals true. It's a predicate. Or x greater than 5. It's another predicate. But it's an expression. So, query plans. So, when you go down in this through this hierarchy of tree nodes, you find query plan. And you've got query plan, the base of logical plan and Spark plan. This is logical representation of what you wrote, and this is the highly optimized query you probably couldn't even think it's possible to write. But if you want to get better at Spark, look at Spark plan. I'm going to show you how. And try to reverse the process of optimizing it and write the query that matches this Spark plan. If you can do this, you are going to write the fastest possible queries on the planet using the latest and greatest of Apache Spark 2.3.1. Okay? Okay, so let's go. So, and by the way, I said that I'm going to show you something. So let me switch. So that's going to be kind of like, let's provoke demo gods and let's see if things can break. If they can, let's see if we can fix them. And if we can do this together, we can learn together, okay? So the more breaks, the better. As a matter of fact, we are here to learn something, right? So if everything goes smoothly, it's something boring. So let's have some fun. Let's play with this and let's provoke God to get angry at us. Okay, so what is this? It's a simple way of saying select star from table called whatever. Okay? I can register a table and I can query for the content of this table. So, just to show you that this is possible also using SQL. So SQL, select star from range 10. I pretend I'm using table called range 10. So this one is equivalent to this one. So now the question is, so let's leave slides. They are talking about this, but slides are already available, so let's have conversation. What's the difference between these 2 queries? Come on, guys, you see it. It does not need artificial intelligence to see the difference. Yeah, come on. Ah, no. Where did he see it? You know, he said something that one is about data frame, another is about data set. Yeah, you might be right. But is this here?
First one is generated and second one is plain string. And the first one is easier to like edit and manage in future, maybe.
Better. It's much better, much closer to what I expected from this crowd. So from you, the difference is none. Meaning, for Spark, Spark doesn't care whether you prefer Scala or strings, meaning SQL. Spark doesn't care. you need proof. Okay. First of all, how to prove it? Control-T, localhost 4040, and I'm going to show you SQLs. 2 SQLs. I apologize, not much to see. Well, I wish I could show you more, but you've got 2 shows, okay? My show, or 3 shows. My show and 2 others. So you've got 2 queries you executed, and they ended up with 3 jobs. So this SQL generated 6 jobs. So starting from 0 up to 5, okay? So these 2 queries generated 3 Spark jobs. This is one way to prove they are same, but that's not all. Better, I'm going to use this because you can see more here. I apologize. You can use console like this if you prefer, if you are older like me, and so you probably will stick with this. If you are younger, you probably prefer the other one. Okay? So Spark range. So let's see how does this look under the covers. Spark range 10. First of all, okay, so I've got my query, okay? First of all, explain this query, okay? So I say, hey, Spark, let's have a nice conversation about my data, okay? Explain me what you are going to do with my query. Done. We've got some nice looking output with physical plan, and this is the plan Spark is gonna execute over your data. So Spark will execute these operations, apply them to your data. What's this star? What's this star? I'm not asking about myself, about this little star. Ah, now I gotcha. What's the star? You see the star here? This is star, definitely this is star. Asterisk. What's that? Yes, for this, we got very low level code written in, generated by Spark at runtime, and written in, what do you think? What's the most crazy language on JVM? No, it's not as crazy as you may think of. It's written in Java. Why? Come on, Java? And this guy who is on the stage was mentioning that, you know, he left Java for Scala, so now he's back to Java. Why is that? The reason is, it's the most optimized language on JVM. In a sense, it's that JVM was designed with Java, so developers decided to use Java because it's, in their minds, the greatest language to generate bytecode. Eventually, you need bytecode, correct? You need bytecode because on JVM, there is no other language like the one and only bytecode. So, but writing bytecode is painful. So they needed intermediate language from our language to generate code. You want to see the code? Yeah, everybody's like, yeah, show me the code. I want to see the code. Even though you will understand nothing, it's like, oh, now I'm relieved. I can see the code. Okay, so I'm going to show you the code. And by doing this, there are 2 ways to see the code. I'm showing you something that's not described in official documentation because, well, it's not for faint-hearted. It's not for people with, hearts that can explode to see, all this beauty under the covers. So this is org Apache Spark SQL. This is the package we are using. And execution debug. After this, you will get this extra query, and this is debug CodeGen. CodeGen is the acronym for Java source code generation at runtime. Spark does this every time you execute query, every time. So if you create a query in any language, Python or Scala, Java, it will get transformed into Java code like this. You can compile it, by the way, and run it rather than using your code. So you could just, push this to your repo and say, I just wrote it yesterday. I was in Odessa, had nothing to do, so I just wrote it. So this is the code that will be generated for every query you execute ever on Spark SQL from 2x up to 231. Things may change, but it's like this. Every time you will see public object generate, it's a Java, that accepts references, and it returns new generated iterator for CodeGen 1, and you will CodeGen stage 1, and you will get as many stages as you will get for your queries. So if you've got something more crazy, like Spark range 5 group by, let's say, I'm going to use this crazy tick, so people get confused. Why didn't I close this? But I don't have to. Okay, and let's say count. What am I creating? What am I calculating? Number of odds and number of evens, numbers, okay? So I separate the numbers into two groups by whether they are divided by 2 or not, and I calculate elements in each group. So I'll get, what I need, show. So, 0, 3. Let's make it a little bit more beautiful. Okay, so I've got this query, okay? Now, I know that this query is pretty complex. Well, it's not, because of the beauty of Spark SQL. But under the covers, it creates fairly complicated query plan. Let's see what it generates. So without this show, I'm gonna queue, and now I'm gonna say, hey, explain the query. This is the very last moment in optimizing any query, so you see physical plan. You see? It's not as simple as it was with this select from range, but you've got 1 star here, this is 1, this is another star, it's 2, which means we've got 2 stages, CodeGen stages, 2 different classes generated for this simple query. Simple. No. Show it to people who are not familiar with Spark and they say, what is that? Did you type it? Oh yeah, I do it. They are paying me for this. Oh, you're a crazy guy. Yes, I am. So, this is what we need to understand Spark SQL. If you can read it, you are crazy. No, that's good. You can expect higher salaries, probably, because you are an expert in Spark SQL. And that says, from the bottom to the top, we are going over a data set that we generated using range operator. This is physical query plan. Then we applied hash aggregation using this physical operator. We had exchange. You should avoid exchanges at all costs. Not currency exchanges. Well, you should avoid them too. But just exchanges in your queries are shuffles. They are very sensitive. You are moving your data from one node to another. So your data is flowing from one node to another. So if you've got 10,000 nodes and you are shuffling your data, you are sending them across your network, that's something you want to avoid, just to make your queries faster. And then hash aggregate again, because this is partial, this is complete. So when you look at this, hash aggregate is keys, is partial. Where is this? It's function partial. Partial count, and this is total count 1, okay? So all in all, start reading it. But that's not what I wanted to show you. How much time do I have? 15 minutes? 20? Oh, very good.
You have actually like 10 minutes.
Half an hour. Thank you.
10, yeah.
Okay.
You heard me.
Okay, yeah. So now I'm going to show you more complex way of looking at things, how Spark SQL sees them, okay? True. Yeah, explain. Let me, extended. So I'm going to use this named parameter, extended, true. Okay, so sometimes it's true, sometimes it's false, depending on method. So that's why I got confused. Now, ladies and gentlemen, look at this. Let's start from the top. First of all, any query in Spark SQL will end up written in Python, Scala, Java, C#, F#, Microsoft open source library that generates, that allows you to use C# or F# with Spark. So it doesn't really matter because they are generators of what? Parsed logical plan. As a matter of fact, you could write your own language and generate all these aggregates, analyze, and range. Okay, just skip this barrier. It's optimized. So range and aggregate or operate are ingredients of most of your queries. Okay, I'm not saying that these are the only operators available, logical operators available, but they are among the 100 or 200 different operators. Out of them, you create any query supported by Spark. In Spark, once you pass this parsed logical plan and go to analyzed logical plan, you know that your query is executable. This is the step from this to say whether your query makes any sense to Spark. So Spark understood your query and said, hey, I approve this query, I can run it. So you've got analyzed logical plan. The difference between parsed logical plan and analyzed logical plan are types. Spark knows types of your data. Look at this. Group is of type big int. Count is of type big int. Spark can reserve enough space, can ask for space to do proper calculations. This is important for optimizing your queries. But this is only logical optimization. It's not optimization. It's just parsing still. But logical optimization happens here. So once you have analyzed logical plan, you move to optimized logical plan, and things get much nicer to our eyes. You see, the screen is readable better, right? So optimized logical plan knows that this query should have been written like this. So Spark said, you are a smart guy, but I can do better. Okay? So it's a conversation between you, developer, Spark SQL developer, and Spark. So if you want to get better, just look what Spark did and try to come up with something even better. And by better, I mean performant. Because Spark, unfortunately, is by default rule-based. There are some heuristics Spark uses to optimize your queries. There are rules. So if these rules don't match your query because you did something crazy, and you can do things called crazy, Spark may get stuck at optimizing it and give you not so performant query. Okay? Why? Because there are only 100 rules. There is available, but not enabled by default, CBO optimization called cost-based optimization that you can enable and expect some further optimizations, but this is not GA yet. It's not bulletproof yet, okay? Anyway, you've got optimized logical plan, and the last but not least, you get physical plan. You see, no stars. Here, there are stars. Yeah, just like on the sky above Odessa yesterday. You see, these are stars. That's to tell you that code generation is only available between having first physical plan and optimized physical plan. It's only when Spark knows what to generate for what query. And Spark does not take your query directly, it optimizes it through rules and gives you the most performant, effective query. And only having this query, this one, wish I could jump as high, and generate this one. Okay? Through different rules. So let me switch to this. So expressions, blah, 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 that's rule. Yeah, I could talk about it. There are some rules you can look at and know how to write your own rules. I apologize for not showing you this in clear, but the point is, it's a partial function in Scala by using case, you can just destructure query and say, for these parts, I'm gonna write something like this. It's pretty simple, okay? Fairly simple, okay, fairly simple. Query execution. So, we used explain, but you could also use something that's called query execution. Query execution is internal representation of your query that ends up like as a data set. Anything written in Spark SQL, I mean any query, ends up as data set. It might be data set of rows, which is called data frame, but it could be data set of custom case class, okay? It doesn't matter. But with any data set, you've got query execution attached, which does all this internal processing. And you know what? That's what I told you. We start with SQL or with dataset, okay? Fine. We wrote our query. It's parsed by parser. And so any method you can look at, and by the way, I'm gonna show you the code of Spark. Why not? So let's have a look at select, not select, where. And where is operator? It's a symbol, it's a function. Oh, you see dataset where. So this where is like filter, you see? I'm not sure if you can see it. Presentation mode, so. Okay, much better, I believe. So where is just filter. So it doesn't really matter whether you are using where or filter. You go to filter and you see what? You see nothing but with type plan, it's a function to generate something around filter. What is filter? It's the logical operator you are using through this API. And for SQL, you have, thank you, you have SQL parser borrowed from Presto, from Facebook, from this database, from also with some influence from PostgreSQL parser and from Oracle. So they combined all this knowledge to create SQL parser and Scala parser to generate logical plan out of these ingredients called logical operators. So filter is among the logical operators available in Spark. So let's have a look what this filter looks like. You see, it's a case class, and this case class extends unary node, which is just a single node in this tree that has just one child operator, which makes sense, correct? So you create tree out of your query, and then there is optimizations. There are optimizations. So you create unresolved logical plan, unresolved because we know nothing about types. Then through analyzer, you created analyzed logical plan. Then you went to caching because some, like, what was the name of the product we should be using? Ignite, yeah. Or we are using Ignite. So through Ignite, we can replace some parts of our query with cached version. This is this step. Then through logical optimizer, we get the most optimized logical query. Then Planner, Spark Planner, will give us the very first and the only physical plan for our query written in SQL or dataset. And I'm not talking about languages, as you can see about dataset. I don't care whether it's Python, whether it's R, whether it's Java or Scala or C#, F#, whatever. I don't care about it. Having that, Spark applies something that's called preparations. These are optimizations on your physical plan to generate the final shape, the final format of your structured query. This is what you see when you do explain without any flags to show the others. Okay? So as you can see, we saw 4 different stages in, and I'm not talking about Spark Core or RDD stages, I'm talking about phases, and only 4, but you know that there are more than 4. There are 2, 6, okay? So all in all, let's show you some. There is analyzer, there is logical optimizer, there is planner, I mentioned, there is physical optimizer, which is the last piece in our query optimization. And what I wanted to show you, and I wanted to plant in your Inception. Have you seen this movie, Inception? So I want to plant this idea. So I'm going to put you into a dream, in your dream. So you see that you used SQL and you generated some code that looks like your query. But eventually, Spark cannot do anything at runtime but to execute jobs that are made of stages, that are made of tasks. So that all I said has to end up as an RDD. So your question could be, why should I be bothered with Spark SQL if I can write all this in RDD using RDD API? And you know what's the answer? My answer to this? Exactly. You don't have time, given this weather, to sit in front of a computer, studying Spark, knowing all the optimizations, knowing all this I shared in 1 hour, and come up with something so performant that you could be proud of. So all this will end up as RDDs eventually. So SQL is nothing like generator of the code using RDD API that you could also write yourself in the first place. But why should you? Right? Okay, I have more, but since our time is gone, so thank you for this lovely conversation.
Hey, great talk. I'm curious about what do you think about like Spark and all the ecosystem and JVM, and also the thing that we see in terms of hardware development. You know, all these new kind of Intel devices and GPUs and everything. Do you think that JVM is going to be not used in big data in future?
Wow, very interesting question. If I may rephrase your question, what's the place of JVM in this big data movement? It's not only about Spark, it's a general question about big data because we've got large data sets and JVM is not very suited or suitable to process objects on JVM because of this garbage collector. Correct? Was this your question?
Yeah, as well as like using like device-specific instructions.
Okay, so may I answer your question? Yeah. Okay, so just to give room for others. So my take on it is like this. I love JVM, and I really wish we don't leave JVM for something else like Rust, like C, C++. Again, no, I'm too old for C and C++. But I know that there is a trend to make things faster by being closer to the bottom, to the hardware. That's why Spark created something that's called, and I need to go back, Tungsten. Tungsten is an engine that avoids copying data onto JVM. Through Tungsten, which you don't have to worry about, it's done automatically. Spark keeps your data outside JVM using Sun unsafe MISC, unsafe, and manages memory on its own. So Spark became another JVM or another garbage collector. So Spark keeps your data away from JVM. And only when you touch your data through case classes in Scala, through data sets, you are putting pressure on JVM to say, hey, now I don't like rows, I like objects. Objects cost you a lot. And you are moving data from hardware onto JVM, you are creating tons of objects, and that's why I said stay away from data sets, as long as you can, okay?
I'd risk to say one more question.
Hello, firstly. So, you told us that if we just write some query to Spark SQL, it wants from us to know what we want to get, and it decides by himself how he wants to get it. It's correct, yes?
Yes, that's correct.
So, then we're getting some execution plan of the query.
Yes.
And like, so what? We get it. We don't know how Spark optimizes it, how it actually works, and we just get some execution plan, and we can a really little space to improve it.
Okay, very good question.
So
and
what are the reasons?
So if I got it right, it was about rules. So remember tree node? And I said everything in your query is a node in a tree, okay? So look at your queries as a tree. Then we've got the different queries, but they eventually create query plans. And you said, so what? We saw physical and logical plans. So what? So what? We know it's a tree. Okay, it's a tree. Okay? So we forgot, we leave all these query plans, blah, blah, blah. We know it's a tree of nodes. And we know that there are also expressions, and also we know that Catalyst came with rules. Rules that transform trees. They could be query plans, logical or physical plans. So through rules you can write, there are 100 rules, you get better query plans or better trees. And this rule is a function that accepts tree and say, if I have this tree, I give you this tree. So either you wanna have this rule enabled or not. Spark comes with hundreds of rules enabled, but you can tweak them, you can disable them, and influence the final query plan that is used to generate the good old RDD-based code with Java code. So to answer your question, so what? When you know the queries, you know there are rules, and eventually you will generate Java code and RDD code that will get executed by Spark. So Spark SQL is nothing else like generator of Java code and RDD. That's it. That's all from me because we ran out of time, right?
Yeah, and thank you
Again.
one more time. Let's give it up for Jacek. I think